Today we're starting the last section for this chapter, 5.8, Solving Quadratic Inequalities. We're going to graph x squared minus 2x minus 15 is greater than or equal to 0. How are we going to graph this? Now, if I do the calculator, it will show me the graph. I'm going to show you how to do this by hand. The easiest way is we're going to take the x-intercepts. I'm going to try to factor this if possible. I know it has to be an x and an x. The signs have to be different. Okay, which one's the 3 and which one's the 5? Positive's the 3, the negative is the 5. What that means is I have x-intercepts at 5 and negative 3. That means 1, 2, 3, 4, 5. That's where one of them's at. 1, 2, 3. Now, is my parabola going to go down or is it going to go up? Why is it going to go up? Well, because the x squared is positive. That tells me up and down. The one thing I need is to know where my vertex is at. Take these two numbers, add them together, and cut it in half. It'll tell me the middle point. What's 5 and negative 3? 2 divided by 2 is 1. So I know my AOS is right there. Now I need to know where my vertex is at. Do you remember what I have to do? Put the negative, or put the 1 into the problem. And I'm just going to put it in right here. 1 plus 3 is 4. 1 minus 5 is, what is it? Negative 4, which tells me my vertex is at negative 16. I can't get 16 on here, so I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. That's my vertex. Pretty close. There's my parabola. Now, thinking about an inequality, this has to be what? Greater than or equal to 0. So I only care when, yes? AOS, take the x-intercepts, add them together, cut it in half. I'm just going to take this. That is the only time it's greater than 0. Now, if I think of this on a number line, what type of statement would this be? What do AND statements do? They connect. What do OR statements do? They go in, I'm thinking on the number line, the graphs go opposite directions. What does this look like? Or, this means x is equal to negative 3 or x is equal to 5. These things help me figure out if it's an AND or an OR. That's what we're going to look at. Do you understand what we did here? We don't have to have the graph. I'm just showing you graphically first. So you understand it's greater than 0. It looks like this. All right, we just did that. We just did that one. This one has to be greater than or equal to 0. On the number line, if I would have graphed it, we saw on the graph there was -3, we saw there was 5. And if I think of this, it's going this way, right? It's never going to get to the -2, the -1, these ones, right? And this one never gets to the negatives. It has to go this way. So my arrows go this way and this way. It's an or statement. Looking at this one. When I graphed it, it was greater than 0 at those 2 points. All right, this problem here. Let's factor it, if possible. Okay, it is possible. X, what did you say? -3, x plus 2. So I know x has to be equal to 3. Sorry. Okay, -2? Can it be -2? Why not?
No, because it'd be -5x.
What does this tell me? They have to have the same sign. They have to have the same sign that multiply to get me 6, but when I put them together, get me a -1. Can I factor this one? No. This one cannot be factored. We tried. What's another method besides factoring? Okay, always look. Can I pull anything out? No. Can I factor it? No. Completing the square. Okay, I don't want to complete the square on this one, because what's in the middle? 1. And 1 divided by 2, I have half. I'm dealing with fractions. So what's my last resort? Quadratic formula. -b plus or minus square root b squared minus 4ac all over 2a. This one always works, but it's a lot more math. How are you going to factor it? They're the same to multiply 6, but when you add them together, get you 1. The only thing you could have got was a 7 or a 5. My b is -1, so it's 1 plus or minus -1 squared minus 4 times by 1 times by 6 all over 2 times 1. And I just realized something. Okay. I have 1 minus 24, which gets me -23. What does this -23 stand for? The discriminant. What does the discriminant tell me? How many zeros I have. How many zeros do I have? 0. That means if I were to graph this, x squared minus x plus 6. It's up there. And I want it, what? I want this less than or equal to 0. Does this ever go less than 0? No. No solution on this one. There's a mistake in it.
What happens if there's no more solution? Yeah. What do we put the I in?
The i's not going to help me. I need to change one thing in this problem. Yeah. All right. Notice what I just changed. It is now a -6. Signs are different. X minus 3, x plus 2, less than or equal to 0. This one now I can factor because the signs have to be different. Since they're different, I have to subtract and get a 1. X is 3, X is negative 2. No, remember I'm changing the sign to find the intercepts.
Oh no, therefore, when instead of being x equals 3, wouldn't it be x is less than equal?
I'll show you. On here. Make it a minus. Graph. Now, what am I looking for? When it's less than 0. It's less than 0 from here to here, right? Why is this an and statement? They connect. This is an and.
So it's only an and statement when it's given where the curve is at.
Right. I'm looking at the curve.
How are we going to be able to tell that it's up?
That's what you're going to do, is you're going to use the calculator to help you. Or look for something that happens. What's that? The first one, this was greater than or equal to 0. If this is greater than or equal to 0, it looked like this, right? Now, if I made this less than or equal to 0, I'll erase. It's now less than or equal to 0. Since it's now less than, what type of statement is that? Okay, less than statement you told me is and, but if it was greater than, it's a, this one is less than, it is an and. So it connects. Looking at this one, just right now, would this be an and or an or? Just, why would it be an or? Greater than. But this is a special type. Where's my x-intercepts? It's just on 2. So x equals 2. That means my only point is right there. It's not a line. It's that my u just touches in one point. I know it's not. When is it greater than that? All the time. So what would this one be? This is all real numbers. It's always greater than or equal to 0. The T with the R attached, yes. How about this one? We would think this one is an and statement. But this is special. What's making these special compared to the other ones? It's a perfect square. What's my 0 at? My 0's at negative 3. Board's not aligned. My u goes like that, right? It needs to be less than or equal to 0.
Well, it's not being less than or equal to 0 once.
Where? At. That's it. This one's different. It's only at one point.
But if that was a negative, how far?
If it was a negative, that would actually take this graph and flip it. And then it would be all real numbers.
Negatives are real numbers.
Here's another one. You have to understand the special ones. Okay, where's my 0? Negative 1. Okay, my graph like that. It has to be greater than 0. When is it greater than 0? Not all the time.
So that's the point.
When it's above that point. So it's all real numbers except
No, you just meant don't think.
oh yeah. Or I can just do this. X can't be -1. It is greater than 0 always except for at -1. That's what I wanted you guys to see. If it is less than or equal to, it is just at that point. If it's greater than or equal to, and it looks something like this, it is all real numbers. If it's just greater than with no equals, it's all real numbers except that point. And the next one you're going to see is, well, I don't have the less. The less than would be what? If this was less than this, it would be all real numbers except then that one. Sorry, I said it wrong. This one would be it has to be less than that. Less than 0. When is it less than 0? Never. No solution. No, less than 0. Not equal to 0. Let's look at this problem. We're going to graph this one. Now, if I'm looking at this problem, how does this problem differ from this one, this one?
It has a negative. Oh no. It has greater than equal to y.
Has a y in it. So all of these ones we can solve algebraically without having to graph. Like if I give you a problem like this, you don't need to graph. You should automatically find the zeros, and then by looking at, okay, it's less than, it's an and statement. Find the zeros, it's a greater than, it's an or statement. But since I have y is greater than or equal to x minus 2 squared plus 1, I need to graph. So on your graph paper, make an xy axis. When I graph this, what form is this in?
Oh no, I forget what it's called. No, that's what it was, the one we just learned. This one I know.
This is in vertex form. In vertex form, this tells me my vertex is at 2, 1. So 2, 1, there's my vertex. That's my vertex. Now, all I need to do is find the points to graph. Really, all I need to do is I'm going to find the y-intercept. So when the y-intercept, what is 0? The y-intercept, what is 0? For the y-intercept, what is 0? X is 0. So that's 0. 0 minus 2, or sorry, yeah, 0 minus 2 is -2. -2 squared is 4. 4 plus 1 is 1, 2, 3, 4, 5. What do I know about a parabola? It's mirror image. So I'm 2 away here, so I'm going to be 2 away over here. It's got to be the same exact thing. I could have picked any point I wanted. I could have picked -1, -10, but it was easier just to put in 0.
Why do we feel like why would we is that x minus 2%?
Yeah. What's that?
Why would we do negative 2? Like it was 2 on this side and negative 2 on one.
Because it has to be a mirror image of this point. This is my AOS right down the middle. So I can draw my parabola. How did I get that 5? I put in 0. I picked x as 0. 0 minus 2 is -2. -2 squared is 4. 4 plus 1 is 5. Yeah, I could put any number in. Except for you wouldn't put in 2, because that would give you 1 again. This has to be greater than or equal to. So is my line solid or dotted? Solid. Where's my shading? Above or below? Why is it above?
So don't make it dotted
You might have dotted U's. That's your answer. Because it is y is greater than or equal to. If this one was less than or equal to, it would be all of that. All right? Try to graph this one. There are a bunch of different ways I can do this problem to find the zeros and the vertex and everything. Some of you are trying factoring. Some of you are using the quadratic formula. Both do work. Let's do the factoring first. I'm going to show you both ways. By factoring, I want to try to factor x, x. What does this tell me? Same, and they both have to be negative. Can I get a 3 from 2? 2 and a 1, right? So my zeros are at 2 and 1. 1, 2. Now, that's skinny if you count by ones. I'm going to change my scale. I'm going to count by halves. There's 1. There's 2. You don't have to count by halves. It's just, I want it spread out a little bit more. I could have counted by fourths if I wanted. If you do by ones, it's going to be really, really close. Now I need to find my vertex. To find my vertex, 2 plus 1 divided by 2. You take your intercepts, add them together, divided by 2. 2 plus 1 is 3 halves, which means 1.5. So it's 1.5. It's on this line. I take this number and put it into the problem. And I can just use the calculator and go 1.5 squared minus 3 times 1.5. You can use fractions if you want, plus 2. Where's my vertex at? So 1.5 comma negative 0.25, or 3 halves and negative 1/4. 3 halves, negative 1/4. If I go by halves again, going up and down, it would be right there. My U is going to be dotted. And my shading has to be below. So it's actually everything below it.
So you put 3 halves back into the problem.
Right. Yep. Now some of you use the quadratic formula. And went negative b plus or minus square root b squared minus 4ac all over 2a. Negative 3 gives me positive 3 plus or minus square root negative 3 squared. minus 4 times by 1 times by 2 all over 2 times 1. 3 squared, 9. 4 times 2 is 8. 9 minus 8 is 1. Square root of 1 is 1. 3 plus or minus 1 all over 2. 3 plus 1 is, divided by 2 is, 3 minus 1 is, divided by 2 is, I still got the same zeros. Someone remembered how to find the AOS. AOS is just the negative b over 2a. So I know it's 3 over 2. Now you take 3 over 2, put it into the problem, and you're still going to get negative 1/4. Either way you want to solve it. Doesn't matter which way. Which way is easier? Whichever way is better for you. I always try to factor it first. If I can factor it, I do the factoring method. If I can't, then I'll go to quadratic formula. This is the vertex right here, same as what I have over here. I just have it written as a decimal. We get the gist of this lesson right now? Okay. So today you learned how to graph them if it was just, or actually how to solve them if it was just a normal x squared minus x minus 6. How do I know if it's an and? Less than. It's an or if it's greater than. You don't have to graph those. The only ones you have to graph are a y less than equal to ones. And then that one has to deal with shading.